Our topic is on limits, and we'll be going over what a limit is and how we evaluate limits. The limit of a function is the value that the function approaches as it gets closer to a certain number, c. In order for the limit to exist, both sides of the function must approach the same value. If the function is continuous as x equals c, then the limit as x approaches c is f of c. If the function isn't continuous, then the limit might not exist. Here we have some examples of functions that are not continuous. In the first example, the limit exists because both sides of the function approaches the same value. In the second example, the limit does not exist because both sides of the function approaches different values.
Here are some properties of limits. Let us assume that the limit of x approaches c of f of x is a, and the limit as x approaches c of g of x is b. If a scalar multiple such as d is multiplied, the result will be d multiplied by the limit, which is a in this case. If the limits are added, subtracted, multiplied, or divided, the result will simply be the sum, difference, product, and quotient respectively of the two values. And if it is raised to the nth power, the result will be the value to the nth power as seen here, which is a to the n.
We have multiple ways of evaluating limits. And for simple functions, we will just plug in the value of c into the function. In this example, we have the limit as x approaches 4 of the function f of x. While plugging in 4, we get that the limit is 7.
Another way to evaluate a limit is the simplification and cancellation method, which can be used if the limit is in the indeterminate form, for example, 0 out of 0. If we have the function x squared minus 2 minus 4 all over x, the exponent can be expanded, which through multiple steps will result in x minus 4, and the limit of that as x approaches 0 is negative 4.
Another way is the rationalization method, which we will usually use if there's a square root in the numerator of the function. In order to solve for this, we will rationalize the function. And in this example, we did it by multiplying by the square root of x minus 4 minus 3 plus 3 over the square root of x minus 4 plus 3. After rationalizing the function, we can plug in c and solve for the limit, which in this case turns out to be 1 over 6.
Another way to evaluate the limit is by using the squeeze theorem. If the function f of x is less than or equal to h of x, which is less than or equal to g of x, and the limit of f of x and g of x as x approaches c is a, then the limit of h of x as x approaches c is also a. For example, if we have f of x equals x to the third power plus 4 to the 1/2 power, and h of x equals the square root of x to the 8th power plus 4, then the limit as x approaches 0 of f of x and g of x both equal 4. So the limit as x approaches 0 of h of x must equal 4 as well.
We can also solve for limits by using a table. In order to do this, we plug in values that gets increasingly closer to c into f of x in order to see what value f of x is approaching. From this table here, we can see that as x approaches 2 of f of x gets increasingly closer to 1. So the limit of f of x as x approaches 2 is 1.
If a limit is indeterminate, another method that can be used to evaluate the limit is by using L'Hopital's rule, which states that the limit as x approaches c of f of x divided by g of x is equal to the limit as x approaches c of the derivative of f of x over the derivative of g of x. Here we have the limit as x approaches 2 of x squared plus x minus 6 over x squared minus 4. The limit of both the numerator and denominator is 0 as x approaches 2. So L'Hopital's rule is used as it is indeterminate. Now we have the limit as x approaches 2 of 2x plus 1 over 2x, which is 5 over 4.